this is the code section for the factorial tutorial. Now this factorial, the first approach which I have said was iterative, right? Now the iterative is, you guys know, sorry, just uh, okay, let's see. So how we are going this first, factorial, now this simple function which is accepting the input from the user, and it will take to the factorial this function, right? Now this factorial function it will take. Now afterwards what will happen is we are declaring a result variable, right? Now that result variable, we are often, sometimes we don't have that much knowledge how to deal with it. So we will simply go with the brute force. Now, how the actual mathematical way is functioning, like we will first declare result equals to 1, because right, if I'm putting it as 0, then what will happen is this thing we will be getting, if result equals to 0, then whatever number I'm just multiplying, it will result to 0 only. So what I'm going to do is I will first initialize this result as 1. Afterwards, then I will multiply it by any number, then it will give the proper result. Okay, so this way we can deal with this problem. So that's why I'm initializing the result as 1, not 0. Okay, so let's begin with this code. Now, as you can see, I had just mentioned it wrong, and I will just rectify it to 1. Now, at this time, this I will go from 1 to n. It's okay if it is not 1. We can go from 2 as well, because 1 is already actually taken, right? So first, it will go for this thing 1. Then first it will go 1 into 2. Okay, 2 it will go inside. Then next, the already result is 2. Now 2 into 3 for the next iteration. Then similarly it will go and will return after this completion. It will return the result. Okay, let me run this code. So I will first keep. Okay, I will just copy this and refresh it. Sometimes for some reason it happens like it takes time. So now I will just run this. Okay, I will keep 5. So yeah, it is, the answer is coming 120. What we need has a what we need has a answer. Okay, so let me pause for a moment and think of a solution in recursive approach. Now recursive approach, I have already showed you this code. This is very important code which we will need in the recursive approach. So guys, just think for 5 minutes, then come back to the video, and we will discuss what the answer actually is. Okay, so this is the actual this thing which I'm not able to write it. That's the problem here in this thing. Let me restart it. So you guys think for this moment about how to deal with it, so that we can go ahead. Now, for example, in this, see the statement which I have told you to include is this only, right? 4 into 3 factorial. So this will come. Now, when is the stop base condition? When the n, when it is coming to 0, here, if the factorial is, if I want to take the factorials to somewhat 1 factorial. So what will happen is 1 into 0 factorial. So in that case, it will come return here again 0. So it will check whether it's 0 factorial, and we know that 0 factorial is 1. So we will return it as 1. Okay, so afterwards, how it will work is this way. What is happening? Now it is working fine, is it? It's not working properly. Let me close this. So for some reason, I was facing some error. Now, how it is working is in the sense, uh, again, there's some. How it will deal with this, like 5 factorial. Okay, now it will go here, has 5. 5. Now 5 is not 0, so it will go here. So 5 into 4 factorial. Okay. Next, seeing this 4 factorial, it will go again and we'll check whether it's 0 or not. It's not 0. So it will go for n into factorial of -1, n minus 1. So it will get 4 into 3 factorial. Okay. Again, seeing this, it will go again, doing 3 into 2 factorial. Again, seeing this factorial, it will go for 2 into 1 factorial. Again, seeing this 1 factorial, it will go again and will print 1 to 0 factorial. Now see, the 0 factorial it will see and it will come here and we'll check whether this n is 0 or not. It will return 1, right? So I will take the color different and it will do, sorry, just 1. 1 into 1 is again 1. Okay. 2 into 1 is again 2. 3 into 2 is again 6. 4 into 6 is 24. Okay. 24. And 24 into 5 is 120. This is the final answer. And it will return same as long. Because long I have to, it has a return because sometimes if it is 10 factorial, it is a very long number. So that's why I'm taking it as long. And here it will return that same thing and we will print the answer. Okay. So this was the recursive approach. Next video would be on trading zeros in factorial. Trading zeros is in sense if I'm doing 10 factorial or something, the number how much we get some number like for example 4200000. Okay, so there are trailing zeros 4, so number of trailing zeros are 4, so this output we have to calculate, okay, after doing some factorial. And there is a very efficient approach also, even that we will discuss in the upcoming videos. Okay, till then I have some break and let's get back to that.